Hi, chemistry students. This is another podcast about percent yield, and here's an example problem. Mr. Goose is going to do one of his demos.
Alright, now here are the materials that we're going to be working with for an experiment here. We have hydrochloric acid inside of a flask here. We have some mossy zinc, and then we have a balloon. What I'm going to try to do is we're going to use the reaction zinc and hydrochloric acid was going to form zinc chloride and hydrogen gas. And what we're going to try to do is we're going to try to capture that hydrogen gas inside of a balloon here. So what I'm going to do is I'm going to take some mossy zinc and I'm going to put that mossy zinc into my hydrochloric acid, which is going to start the single replacement reaction. And then I'm going to take and put the mouth of the balloon here over the top of the flask and try to capture the gas. So here we're going to put some mossy zinc into our flask. We're going to cap this with our balloon, and then the balloon is going to eventually get filled up with the gas being produced by our reaction. As you can tell here, we're still producing hydrogen gas. We're starting to actually collect a fair amount of it here, and then we're going to use that for demo we're going to do in a little bit. So when our reaction is finished, I'm going to try to seal off as much hydrogen as I can inside the balloon, and then seal my balloon. So in here is our hydrogen gas. We can measure how much hydrogen gas we actually produced.
Alright, now I took a couple measurements in the lab, so we're going to use those to try and figure out how much of the hydrogen gas we produced and how much should we have produced. So from those measurements, our zinc that we started off with, I started off with 10 grams of it, and in the end I was producing the hydrogen gas. That's what I'm trying to measure. I was also producing the zinc chloride, but I can't really measure that. I produced 0.1 grams of the hydrogen gas. So what the question here is asking is, what is the percent yield? So our percent yield, our equation for that we know, is actual over theoretical times 100 is equal to our percent yield. So what I need to find out is our actual yield, I give you in the problem right here, is the 0.1 grams of hydrogen. What a lot of my students do, they try to use 10 grams as the actual yield. That's actually a different substance. We're trying to find the actual yield of the hydrogen gas. So what we need to do to find out a theoretical yield is we always need to do a stoichiometry problem. So I'm going to set up a stoichiometry problem to figure out how much hydrogen gas should we have produced. So in that stoichiometry problem, we're going to start off with 10 grams of zinc metal. What I need to do is find out how many grams of hydrogen should I have produced. So I have grams, so I know that grams are going to go down here in my equation, grams of zinc. Turn that into moles of zinc, so that way we can do our mole to mole ratio. So our molar mass is 65.39 grams to 1 mole of zinc. So we don't stop there. Now we need to go from moles of zinc to moles of hydrogen gas. And this is our stoichiometry step. We need to use our mole ratios from our balanced equation. This happens to be 1 to 1. And then we're going to do another stoichiometry problem, or another stoichiometry step, where I go from moles of hydrogen gas to grams of hydrogen gas. And so we're going to use our molar mass relationship again. So we go and we solve this. This is going to give us 0.309 grams of our hydrogen gas. So, the question then is going to be, what was our percent yield? Well, this value that we calculated in our stoichiometry problem, that is our theoretical yield. So when I set up my problem then, we're going to take the 0.1 grams of hydrogen from our problem, that's our actual yield, and divide that by our 0.309 grams of hydrogen from our theoretical yield, multiply that whole thing by 100, and when we do that, we find that our percent yield for this experiment was approximately 32.36%. So there are lots of places I could have lost a little bit of that hydrogen gas. We could have lost it before I put the balloon on. Maybe some of the gas got away. Maybe when I opened it up, maybe there was some of the gas still in the flask when I sealed off the balloon. There's lots of different places that could have been lost, but this is the actual amount that we recovered at the end of our experiment. Alright, so let's take a look at why Mr. Gusa does this as a demo.
So the demo that we're going to be doing here with our hydrogen gas that we produced is we're going to be making water. So we have pure hydrogen in here, pretty pure hydrogen, H2. What we need to do is combine that with oxygen, which is in the room here. We can make water. However, that requires a little bit of heat. And so I'm going to use a match here to start our reaction. So when this produces the heat, it should produce it pretty quick. So here's our hydrogen balloon.